So in this video, we're going to talk about the idea of oxymercuration demercuration reaction. Now, the idea is that if you take an alkene, so in this case, I'm just going to draw a regular alkene, and we actually add the reactants, the reaction in a sequence. So we use HgOAc2, and the second step we use sodium borohydride or NaBH4. And the idea is that we create an alcohol. So we do it across a double bond, and we create an alcohol. Really what we're doing is adding H2O, right? So we have our hydrogen, and then we have our OH right there sequentially, right? Now, oxymercuration-demercuration gives you what we call the Markovnikov product, or the Markovnikov rule, which says that our nucleophile, which in this case is the water molecule, would occur on the more substituted carbon. So in other words, the OH, or the hydroxyl group, will occur on the more substituted carbon. So let's look at a couple examples. If I take this molecule and I add the reagents. The second step, I had sodium borohydride as a reducing agent. What is the product of this reaction? Well, the first thing I want you to do again is note that across the double bond we actually have carbon 1, and let's say this is carbon 2. Carbon 1 is more substituted because it has one less hydrogen. So I want you to think of more substituted. When I say a carbon is more substituted, think of it as the carbon atom having less hydrogens. So less hydrogen the carbon atom has, it's more substituted. So therefore, carbon 1 would be more substituted than carbon 2. So therefore, we should expect the OH group to be on carbon 1. Right? So therefore, if that is the case, then really what we're doing in this case is adding the OH group to carbon 1, and we're losing the oxygen, right? So again, this is a CH3 right here, and you can see that the additional H corresponds to this, and then we have our OH. So really what we're doing is adding water across a double bond, right? Again, on the more substituted carbon. So keeping that in mind, try this one. If we take this molecule and we add, in the first step, mercury, and the second step, NaBH4 or sodium borohydride, these are the reagents for oxymercuration-demercuration. What would you expect to be the product? Again, the OH group is going to end up on the more substituted carbon, and so therefore we should expect this molecule to be the product. Right? So again, if you look at it across the double bond, which carbon is more substituted? This carbon has one hydrogen. This carbon that the OH group is on over here has 0 hydrogens, has no hydrogen. So therefore, and let's label it. So let's say this is carbon 1, and this is carbon 2. So on carbon 1, we really have no hydrogens. So therefore, whereas on carbon 2, we have one hydrogen. And so carbon 1, because it has no hydrogens, or less hydrogen than that of carbon 2, it is more substituted, and therefore we should expect that our OH group is going to be on carbon 1. Right? And that's the general gist of oxymercuration-demercuration. Again, you're adding water across an alkene, giving you the Markovnikov isomer, or in other words, the OH group is going to end up on the more substituted carbon.